How's it going? So today we are going to factor quadratic expressions and reveal the zeros of the functions. But first we have a warm-up, and the warm-up is if x plus 4 times 3x minus 1 equals ax squared plus bx plus c, what is the value of a plus b plus c? So it looks like this. And what you want to do is you distribute the two functions here. So then you have 3x squared minus x plus 12x minus 4, which ends up equaling 3x squared plus 11x minus 4. And so now you got your quadratic expression. And what you want to do with it is you take your a, your b, and your c, and you combine them. So a is, in this situation, 3, plus b, which is 11, plus c, which is negative 4, which gives you a total of 10. But, so now, for today, we are going to basically just do the opposite of what the warm-up was. We're basically going to work backwards, and we're going to start off with that equation that we found, that ax squared plus bx plus c. And we'll do and we'll put a problem up, and then we will solve that problem and go from there. We'll start off easy. So the first question, we have x squared minus 7x minus 18. And so what you want to do is you want to factor. So what times what equals this expression here. And we can first see that it's x squared. So that means each set of parentheses will have an x. And now we got to think of what times what gives us negative 18, or just 18. And we got 18 and 1, plug that in, doesn't work. We have 9 and 2, we also have 6 and 3. You plug in the 6 and 3, and that doesn't work out because 6 and 3 is for the negative 7. And it's a minus minus. It's x squared minus 7x minus 18. So that means in the parentheses, you'll have one of them have a plus sign, the other one a negative. And so we'll do that. And then we think of the possibilities. Let's try 9 and 2, right? So, and we'll go, if we get positive 9 and negative 2, that will give us a positive 7x, but we want a negative 7x. So therefore, we'll do x, it'll be x plus 2, and then x minus 9. So right here, this is what it comes out to be. And we're not done, because now we gotta find the zeros for the equation. So what you do is you set these equal to 0. And so then after you split it up, you go x plus 2 equals 0, x minus 9 equals 0. And then you solve it out, so then x equals negative 2 and x equals 9. And that is where your function will be 0 on the x at these numbers when you plug them in. Okay. And so now I'd be giving out a page to work on. Page of all the problems. And I'd have you factor and solve all the expressions, find the 0 for all the expressions. And if it doesn't factor, write non-factorable or DNE. So let's do another one. Let's try to get a little tricky here. We'll go with number 3, which is m squared minus 9m plus 8. So you want to do the same thing. You got to find the two factors that combine for 8. And also, you see there's 1, it's squared, so you know there's only going to be 1 in each set of parentheses. And we think of multiples of 8. And we have a negative 9 here. So yet again, but this time we have a negative and then a positive. It means both answers in here will be negative because negative times negative is positive. And then the negative m's will combine for a negative number here. So we plug in. And how do we find negative 9 but the factors of 8? Minus negative 8 and negative 1 will give you positive 8, right? And that also equals 9m, because if you distribute it right now, you have m squared minus 8m minus m plus 8, which combines to m squared minus 9m plus 8. You can see here. So now, yet again, we want to find the zeros. So you set the two factors they made equal to 0. And so now we have m minus 8 equals 0 and m minus 1 equals 0. You solve it out and we have m equals 8 and m equals 1. That was a little trickier than the first one, but that was also pretty basic. So we're gonna get even more into it now. We'll go over, let's go over number 6. Now number 6 states that 7k squared plus 9k. Now this may look a little scary because there's a number outside of the letter here, and there's also no constant, no other following number. But what you can do is you can take out, there's something in here that is consistent, and that's k. So if you take out a k, right, you would have 7k plus 9. Because when you plug the k back in, you'll get 7k squared. And then 9k if you plug this in. You distribute it back. Feeding the fish is what I learned. It's like you're distributing in each variable. And so now you must be like, how do we solve that? So we'll set k equal to 0. And then 7k plus 9 equal to 0. And oh, bang, we already got the first one. Make the k equals 0. And we'll solve this one. So it's 7k plus 9 equals 0. You subtract 9 from both sides, so you have 7k equals negative 9, because you want to get the variable by itself. Always want to get the variable by itself. You divide by 7, and you have k equals negative 9 sevenths. So where it's 0 is k equals 0 and negative 9 sevenths. We have time for one more. This is repetitive stuff, but once you get a hang of it, it just goes quickly. Like just right through your head. We'll go with number 10. Number 10 says x squared minus x minus 44. And we can just go ahead and just set the function equal to 0, because eventually we're going to have to put it equal to 0 anyways. And you do your 2 factor parentheses here. See the x squared, you get the x, you get the x. But now we think, what times what will give us 44? 44 and 1? 22 and 2? Or 4 and 11? I think that's about it. But what you see is you have a negative x here. So none of those combined terms that we listed, the factors of 44, will give me a negative x outcome. So therefore, the equation itself is unfactorable. So we will write D, N, E. And what I would do is just, for the rest of the class, work on the sheet, and whatever you don't finish, you finish up for homework for the next class. All right, thank you.